So now let's have a look at question number 9. This is the application of calculus, but let's read the statement first so that we can understand what is basically taking place over here. They say to us in the figure below, triangle ABE has a base of length x meters. So let's go look at this triangle that they are talking about. They are definitely talking about triangle ABE, and then this will be the base of the triangle with length x meters. The base and the perpendicular height of the triangle add up to 10 meters. So basically the base, in this case, our base it is x, right? Meaning the base and the perpendicular height, which is h. The base and perpendicular height, which is h, they will add up to 10 meters. This is the information given on the statement. The triangle is mounted on a rectangle BCDE, which has a perimeter of 32 meters. So they say to us the triangle, this triangle BCDE, let's go look for it. BCDE, it is mounted. The triangle is mounted on top of this rectangle, right? And the perimeter for that, which is indicated, the perimeter, the formula for perimeter, it is given by what? When we talk about the perimeter, we add all of the sides of our figure. In this case, our figure, it is rectangle, so we add all of these sides one by one. BE plus BC plus CD plus DE. But in this case, we know that this is length and this will be our breadth, right? So I will just multiply two breadths and I will just multiply two lengths. So this is the addition of all of the sides that we see in our rectangle, right? So this is the information that is given to us on the diagram, based on this diagram that we see over here. And now let's have a look at how the question is being asked. Now, 9.1, they say to us, show that the area of triangle of figure ABCDE is equals to this. So basically, we are going to determine the area of the whole figure. What is the name of the figure? It is called ABCDE, meaning we are looking for the area of the whole figure, right? And if you have a look at the figure, it is composed or it is made up of two shapes. It is made up of a triangle and it is also made up of a rectangle. So if we want to determine the area of the whole figure, what we do is we add the areas of the known shapes. Now the area, let's see how are we going to calculate the area. We're going to say the area of our figure, which is A, B, C, D, E. How do we determine the area of that? Like I said, we're going to add the area that we see within this figure, the area of the shapes that we see within this figure. The first shape, it is triangle ABE. So what is the area of a triangle? We know that it's going to be half base multiplied by height. This is the area of the first shape. And then the area of the second shape, which is for rectangle, we know that it is given by 2 length multiplied by breadth, LB, right? So that will be the area of this shape that we see over here. It's a combination of the whole figure. The combination of these two areas, it is the area of the whole figure. So now in this case, it's important now to understand our values that are provided. And do not forget, we should determine the area of triangle ABCDE in terms of x, just like how they showed us over here in terms of x. So our B is supposed to be in terms of x. Our H is supposed to be in terms of h. Our L and B this side, it's supposed to be in terms of x. Okay? They are all supposed to be in terms of x. Firstly, let's talk about B. So now, if we have a look at B, let's go to the triangle because this is the area of a triangle. We say it's gonna be half multiplied by base. The base is gonna be from here to there, and then h, which is the height, is gonna be here. So we can see that our our base over there, it will be equals to x. So already we can see that our b, it is in terms of x, which is the base of this triangle over here. So for B part, we are sorted. Now let's talk about the h. Recall that they said to us, x plus h will give us 10 meters. So from this equation, we will make h the subject of the formula. So when we make the h the subject of the formula, we can see that our h will be equals to 10, we transpose x that side minus x. So now our h, it is written in terms of x. So we are sorted for B, we are sorted for h. Now let's go to the rectangle. This is the area for rectangle 2LB. Now L is from B to E. Again, our L, we are sorted that we can see that our L, it will be equals to how much? It will be equals to x, which is the length of the rectangle. And then the breadth of the rectangle, in terms of x, let's see. The breadth meaning is going to be the side, right, of a rectangle. So in this case, in order for us to determine the breadth, we can make use of this formula of perimeter. Recall that we were told that the perimeter of the rectangle is equals to 32. So we substitute 32 on this side and then 2, and then the B, it is what we are looking for, and then the L, recall that we said it is equals to x. And then now what I'm going to do is I'm going to divide the whole equation by 2. So 32 divided by 2, that will give me 16. And then when I divide by 2 on this side, I'm going to have b plus x. Then I transpose my x to the other side of the equation. Then my b, in this case for the rectangle, will be 16 minus x when I transpose this one on this side. Then my b will be 16 minus x. So I'm sorted for all of these guys in terms of x. Now let's go substitute. So now we have 1 over our base for the triangle, we said is going to be x. And then our height for this triangle, remember, we got it from this equation. We said it's going to be 10 minus x. And then our length for rectangle, which is BE, is going to be x. And then our B, we got it, well, we derived the value of B from this perimeter equation. We said that the B will be 16 minus x. Now we substituted every parameter in terms of x because they wanted us to calculate the area of triangle ABCDE in terms of x. Now let's work it out algebraically. So what we're going to do is we multiply everything. So 1 over 2 multiplied by x multiplied by 10, we're going to have 5x, right? 1 over 2 multiplied by x multiplied by negative x, we will get negative 1 over 2x squared. And then on this side, we're going to have 2x 2 multiplied by x multiplied by 60, right? That will give us, I think, 2. Will that give us 22? What? 2 multiplied by 16. And then that will give us, oh, I made a mistake. The area of rectangle, it is not 2LB, it is LB, okay? It is not 2LB, it's gonna be LB. So we don't have 2 over there. Length multiplied by breadth, that's the area of a rectangle. So meaning we're gonna have x multiplied by 16, that will give us 16x. And then x multiplied by negative x, that will give us negative x squared. And then now let's consider adding or subtracting the like terms. Let's start with the higher degree, x squared and x squared. Negative 1 over 2 minus 1, that will give us negative 3 over 2x squared. And then 5x plus 16x, that will give us 21x. And then this is the area of ABCD in terms of x. We put our units there at the end because recall that everything, the parameters are given in meters. The units, we use the meters. So that will be meter squared because this is the area, and then will be the same as this one. Now we are done with question number 9.1. Do we understand 9.1?
I understand.
Okay. Thank you. Now we are heading to 9.2, and in 9.2 it says to us, determine the value of x for which A, B, C, D, E has a maximum area for 3 marks. Now, this is where now we are applying calculus. This is the application of calculus, right? So we call this application, there is a concept that we named maxima and minima. So when they talk about the maximum area, what do they actually talking about? Now, this is what I want you to understand, okay? Calculus is very huge in terms of application. So when they say maximum, meaning the peak, we are talking about the peak, okay? Look at this equation. Look at this equation, negative 3 over 2x squared plus 21x. This is the parabolic equation, right? This is a parabola, ne? Uh, um, um, or it's a quadratic equation. And then if we were to present this equation in terms of the functions, this is parabola and the value of a is negative, so it will be concave down, meaning it's a set face because the value of a is negative. So meaning it has a maximum point. The reason why they say to you, determine the value of x for which this will be maximum, it's because the equation that we got for area, it is a parabolic function, and it is a parabolic function that has a maximum point. If the value of a here, it was positive, then our graph will be like this. That means we have the minimum point. We no longer have the maximum. This is the minimum and this is the maximum. So hence why I'm saying to you, you need to understand your basics very well. So when they are looking for maximum, mean they are looking for maximum point of your parabolic function, which is this point over here, right? If I were to draw my Cartesian plane, therefore this will be maximum point. But here, if I were to draw my Cartesian plane, therefore this will be the minimum point. Hence why here they say maximum. So now, according to laws of calculus, what we're going to do is we're going to take this function, the area of A, B, C, D, E. We're going to determine the first derivative of that area, right? Let's rewrite it. Here's the area in terms of x as a parabolic function, right? And then we're going to take the first derivative of this. So I will tell you why we take the first derivative. So the first derivative, when we derive in respect to x, we're going to multiply the exponent with the coefficient. So we're going to say 2 multiply by negative 3 over 2. That will give us negative 3. Subtract 1. We have to the power of 1. Then the exponent is 1. Multiply by 21. That will give us 21. Subtract 1 will be 0. And anything to the power of 0 will give us 1. Now, this is the first derivative of this curve or the parabolic function or the area, right? So why did we determine the first derivative? We determined the first derivative because at maximum point, this is the maximum point, at maximum point, the first derivative of this parabola, at maximum point, the gradient of a tangent will always be equals to 0. So now the reason why we determine the first derivative, it is because we want to equate that to 0. Why? Because at the maximum point, the gradient of a first derivative, it is the gradient of a tangent, by the way. First derivative represent the gradient of a tangent. So at maximum point, the gradient of a tangent, because a straight line, remember, we have a straight line that looks like this, we have a straight line that looks like this, we have a straight line that looks like this, we have a straight line that looks like this. The straight line that looks like this, the gradient of a straight line that looks like this on your Cartesian plane, it is 0. So that is why we say our tangent, it is a straight line. So the tangent here at the maximum point, its gradient will be equals to 0. So the first derivative of a curve, whether it's a cubic curve or it's a parabolic curve or it's an exponential curve, as long as you take the first derivative of that curve, just know that you are calculating the gradient of a tangent. Your curve could look like this, and then maybe the equation of this curve is f. If you take the first derivative of this graph, we have many tangents that we can talk about, right? We can talk about the tangents that touches the curve. So that's the reason why we say the first derivative of this function will be equals to 0. We equate that to 0. We have negative 3x plus 21. Then we have our 3x this side is equals to 21. We divide both sides by 3, and then our x will definitely be equals to 7. And then now we managed to solve question number 3. So I was just explaining to you, why do we take the first derivative and why do we equate it to 0? We could equate it to any number, but we chose for 0 because it is at maximum. Okay, the gradient of a tangent. So do we understand how to solve 9.2?
Yes, I understand.
Okay. And then now we are heading to 9.3. It says to us, hence determine the maximum area of um, figure A, B, C, D, E, right? So to determine the area of this figure, the maximum area, by the way. So to determine the maximum area, what we're gonna do is um, we go back the value of x that we got. Remember, this is the x at the maximum, right? If this is a parabolic function, our x is positive 7. So mean the x here at maximum, it's that. So when we talk about the area, we are talking about the shape below the curve. The shape below the curve. This is the where our calculus comes in for graphs. But in this case, we need to calculate the maximum area, you need the x at maxima. Do you get my point? So we go back to our original equation. Do not substitute it here, because when you substitute, you're gonna get your 0 back, which is the gradient of a tangent. So at this point in time, we use the original equation, which is negative 3 over 2. We substitute our 7 over there to the power of 2 plus 21 multiplied by 7. Then when we punch this on our calculators, let's see how much do we get. And then the answer is 73.5 meters squared. Therefore, this will be the maximum area of this shape. Okay, so yeah, that's it.